Let's do a comparison between two complex numbers. So z1 is equal x1 plus I y1, and z2 is equal x2 plus I y2. These two complex numbers are called equal if and only if x1 is equal x2 and y1 is equal y2, which means the real and imaginary parts are equal. Okay, let's take example. z1 is equal 1 plus I y. Oh, let me put this one as an index. Okay. And what else? z2 is equal x minus 7I. So, and it says that for what x, the question is, for what x and y, these two complex numbers are equal. Okay. By definition, two complex numbers are equal if their real numbers are equal and imaginary numbers are also equal, which means these two complex numbers will be equal only and only if x is equal 1, right? And y is equal negative 7, which is going to be your answer. Okay? Two complex numbers in trigonometric form. Trigonometric form, z1, that is equal r1 cosine phi1 plus I sine phi1, and z2, complex number z2, that is equal r2 cosine phi2 plus I sine phi2 are said to be equal if absolute value of z1 is equal z2, which means argument of z1 is equal argument of z2 plus 2 pi n. Why 2 pi n? Because we are dealing with sine and cosine, and their period is 2 pi. After going, let's say your angle is here, so 2 pi, it's the same result, right? Another 2 pi, same result. Another 2 pi, same result. So it can go as long as it divisible by 2 pi n. So it's going to be the same answer, same result. Okay, and so that means if their modules are equal and the arguments differ by multiple 2 pi, we still can say that they are equal complex number in trigonometric form. Likewise, for the exponential form. So for the exponential form, if we have z1 is equal r1 times e to power I phi1, okay, and z2 is equal r2 e to power I th2, right? So these two complex numbers are said to be equal if R1 is equal R2 and theta 1 is equal theta 2 plus 2 pi n. Again, why we do 2 pi n? Because we are dealing with sine and cosine, and their period is 2 pi n, which means every 2 pi times n times whatever n it is, you are going to get the same answer. Okie dokie. Thank you for watching.